Infrastructure as Code with Joe Duffy.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your humble host. And make sure to check out www.azuredevops.show for past episodes and show notes. And I'm excited that lots of people are taking me up on my open invitation to speak virtually at your .NET user groups. I'm doing quite a bit of virtual speaking now, and it's a lot of fun. And if you run a .NET user group, I'd love to get on your schedule. And if you are tuning into this podcast for the first time, the Azure DevOps Podcast is for developers who are shipping software with Microsoft technologies. And my goal for you and all development teams is that you'll be able to move fast and deliver quality and run your systems with confidence. And if you have some specific issues, well, that's what we do here at ClearMeasure, who is the primary sponsor of this podcast. And so without further ado, let's get right on to the show. Joe Duffy is here with me, and he is the CEO of Pulumi. And he also worked for Microsoft for a number of years, helping them take .NET to open source. And he currently focuses on infrastructure as code and cloud engineering. So Joe, welcome to the show. How are you, sir?
I'm awesome. Thanks for having me, Jeffrey.
Now, we're going to get into infrastructure as code, but you were at Microsoft in the thick of it when .NET was open sourced, and that's a huge change. I think there's a lot of developers listening to the show who weren't even in the industry when that happened, but that was a tectonic shift for a lot of people. What was that like in that era? What do you remember?
Yeah, I mean, it was absolutely incredible. And just to be clear, I played a very small role in that whole effort. It was very much a team effort, but when my manager, several layers up, brought me in one day and said, Joe, I need your help with a project. We're going to open source .NET. We're going to take it to Mac. We're going to take it to Linux. And oh, by the way, we need to do it in like 6 months. So I did not expect that going into the conversation. And it was great. I mean, it really kickstarted this open source renaissance that we see, at Microsoft. And really, it's incredible many years later. I think it was 5 years ago, maybe, that we started that project, that I see VS Code in places that I would have never imagined seeing it before, in the Bay Area with startups. And the interesting thing is that whole change was as much about changing the culture of Microsoft as it was the technology. I remember, after getting that mission, I kind of went to my team and I said, hey, anybody who wants a MacBook, get a MacBook. And I think, over 50% of the team decided to do that. But then they quickly realized, oh, wow, that, if I have a MacBook, which most developers do in at least in certain areas, we can't use Visual Studio. We can't use .NET. That's crazy, right? Like a significant part of the audience just can't even use these great tools and technologies that we've been building for many, many years. And, I joined Microsoft on the .NET team back in the early 2000s. And so I had that history with the project. And so it's a very proud moment to be able to help with, that project.
Yeah, awesome. And you mentioned the point about MacBooks. I think there was a 1.5 year period when I was running a MacBook Pro with Parallels. I forgot what year it was, but there was a time when you looked around at all the hardware and you said, forget operating system. The MacBook Pro is the most compact, highest powered laptop that you can get. And I mean, you look around at Dell and Lenovo, and it's like the whole package. It's like, no, this hardware just works, even if you're running Windows on it, just because it was a great laptop. And then after a few years, the others caught up, and now there's a handful that are all really great. But yeah, there was a time when, regardless of the operating system, it was just the best computer for development you could get in laptop form.
Yeah, and to this day, I use a MacBook. I have Windows PCs as well, but the display is remarkable. It is. They have a number of different compact forms, and so. But I think the key is, at that time, you go to a developer conference, your average, think of a JavaScript conference or something, you'd see all MacBooks. You go to the local cafe, see all MacBooks, and suddenly the whole team realized this means these people can't use our tools. I mean, you can run it in parallels, but it's not quite as seamless as having a native experience. And so the whole team just got fired up over that opportunity. And it was largely motivated also by Azure. We saw a ton of Linux usage in Azure. And as people were adopting Linux, they had to abandon the .NET toolchain. And that was not good, right? We were basically losing on both sides, both on the operating side and on the developer platform side. So bringing the .NET framework and all that great goodness that developers love to their favorite platforms was really the mission. And I can't believe the team pulled it together so quickly. And seeing Scott Guthrie, on stage with, I think Scott Hanselman might have been doing the demo on Mac was just like mind blowing.
Yeah. And now with everything open source, I remember there was I was looking at a way just to test a SignalR hub, and I thought, you know what? Let me just go look at the tests inside the SignalR code base because they did it. And so many opportunities are opened up. But today, we're talking about a hard problem, infrastructure as code, and still to this day, so many people think, okay, I need to create an environment so that I can deploy some software system to it. And so they put their hand on their trusty little mouse, and regardless if it's a VM or Azure, they're clicking their mouse to set up the server or the compute environment. And then, of course, once it's all set up later on down the road, it's, let's change it. Oh, how is it set up? Who has access to it? Do you remember? Oh, we need to recreate one. So it's a hard problem, and everybody knows it. You've been pouring your brain into that problem. What have you learned? Because you've got a take on this.
Yeah, and it's funny because people look at my background in development platforms and managing the languages group at Microsoft, and they say, "Hey, why did you decide to spend time on this problem?" And the reason is, I think for me, the cloud is changing everything about every aspect of how we develop software, and yet it hasn't fundamentally changed many aspects of that. You think of how, as a developer, how do I approach building an application? At what point do I start thinking about the cloud? It's often very late. It's like, I built my application. Oh, now I need to stand up a VM to run it. Or, oh, now I need to provision, a Kubernetes cluster to run containers. Well, I'll have my infrastructure team do that. I'll kind of kick it over the fence and they'll take care of it. And what we saw is the opportunity to say, no, the cloud is part of your application architecture on day one, as you're designing it, as you're implementing it, as you're testing it. And then, there are certain aspects that your infrastructure team needs to manage, like how the networking happens, security, the cluster, and how to scale that up and down, and some of the really gnarly, kind of hard operational problems. So with Pulumi, we sort of approached it from more of a, let's imagine a great developer experience, and let's actually give infrastructure teams a great developer experience too. And by doing so, we'll break down the wall between developers and infrastructure teams. And we call this cloud engineering, which is kind of, organizations that work together to deliver solutions that are cloud native from day one, where the cloud isn't an afterthought. And infrastructure as code really is a key technique for accomplishing that. You think of how do you program your operating system in a normal application? You don't treat it like something completely foreign and different. Like, you don't go write a bunch of YAML to configure the threads and the processes and the file handles that you're using. You just write some code, and sort of the operating system takes care of the resource management. Mm-hmm. So we sort of took a similar approach to infrastructure as code, where you use general purpose languages, you've got a cloud object model, and infrastructure as code is the technique for reliably deploying, provisioning, updating, destroying infrastructure.
Okay. Now, with Azure, you got ARM. So you looked at that and said, okay, either it's too low of a level or it's too different. It doesn't solve the problem. So talk about the problem a little bit and how it's not solved with ARM.
So I think of ARM or Azure Resource Manager is kind of the acronym. So there's a templating system, but ultimately ARM is also an API. So to me, it's a number of things, and right. So the templating is how you would express, hey, here's a bunch of infrastructure that I need. But increasingly modern cloud architectures are complicated. There's a lot of moving pieces. They move quickly. You've got a blob store over here. You've got a Cosmos database here that's scaling globally. You've got function apps scaling alongside it. You might have a service hub thing over here, and you've got you're using AKS as well, and then a bunch of VMs and networks and disks and things like that you have to manage. So it's pretty complex when you start getting into it. And ARM templates are JSON files, and they've got a little bit of a templating syntax in there in recognition of the fact that it's complicated. But let's say you want to do a for loop. You want to say, I want 5 VMs, or I want to scale my Cosmos database across these 5 regions. And for every region, I want to have a standard architecture, but maybe in the EU it's going to be slightly different for GDPR reasons. Expressing that in an ARM template, lots of copy and paste. You're going to end up with thousands of lines of JSON before you know it. And then that's not even to start even talking about, if you're doing Kubernetes, you're also going to have YAML files that you need to manage. And these things don't know about each other. And now you're going to stitch these things together with PowerShell scripts or Bash scripts or whatever. And then you give that to your developers, and most developers are going to look at that and say, no, thank you. And now you're left with this divide, right, where developers and infrastructure teams aren't collaborating closely. And so that's kind of why we took the approach of bring your favorite language. You've got classes, you've got functions, you've got for loops, you have packages. If you want to have a standard architecture, why not package that up in NuGet and share it with your team? So you're not recreating the wheel every single time. And this has been really powerful. And this is why it connects with developers. They get to use great tools, IDEs, test frameworks, et cetera. But infrastructure teams are toiling away far less with copy and pasting YAML and JSON all over the place.
So when we talked about infrastructure as code as a concept a little bit on the podcast, but we've never, and I think you found, the problem's not solved in the industry by any means. People are still just searching for it and learning about it. I think very few people have probably really solved it, even with homegrown or stitched together solutions. But how do you think about the different levels of infrastructure? For instance, you have a particular application. Well, maybe there's 10 applications at your smaller size company. But in Azure, you start with, there's Azure Active Directory at the highest level. And then there's some number of subscriptions. And then and maybe there's one subscription per major system. But then there's the networking and the firewall and maybe several applications run within that. So how do you reason about the different levels? Because an application's Git repository, regardless of the format, can't really own everything. So how do you separate those?
Yeah, it's a great question. It's a very important question because it gets to the point of how infrastructure teams and developers work together. At some level, I despite the fact that we're bringing great languages, I don't expect most developers to want to go deep on how to set up lots of subscriptions and the connections between them and the networking and all the stuff that, frankly, the infrastructure team are experts in. And yet there is what I'll call application infrastructure, which is, container registries, the service definitions for your applications, some of the data stores, whether that's blob storage or pub subtopics, databases. And so the question is, our approach is it's a policy decision who manages what aspect of that. And so we approach it by giving tools to manage the connections between those bits of infrastructure using one consistent approach so that you as a team can decide, for my team, where does that boundary make sense, right? Where am I going to draw the line between the low-level foundational infrastructure that the infrastructure team is going to manage versus the high-level application infrastructure that, frankly, infrastructure teams don't want to be on the hook for. They'd rather empower their developers to move faster so long as they know they're doing it, with the right guardrails in place. And that requires, tools and techniques. And so with Pulumi, we have the notion of projects and something we call stacks. And that allows you to basically say, hey, I'm going to have a project for my base infrastructure. I'm going to have a project for each of my microservices. And then for each one of those, a stack is an instance. So you can say, my base infrastructure, I've got, one on US East, one in Europe. You can stamp out many of them. You can have private development stacks. You can have testing ephemeral stacks that you're going to spin up and tear down just for validation purposes. I think that's a key ingredient for helping teams navigate the complexity.
Okay. And so would you, let's dive into the Pulumi approach a little bit. Do you consider it a competitor with, say, Puppet, Terraform, or is it at a different layer where you use those in addition to? Where is it positioned?
So we integrate with Chef, Puppet. In fact, we have an adapter layer, so you can use any Terraform provider from Pulumi. And Chef and Puppet are great for virtual machine configuration, which we're not really in that business. You can use Pulumi to do that, but we'd rather integrate with existing, tried and true solutions there. The same is true of Ansible and SaltStack, for example. I think Terraform is maybe the closest, direct replacement. A lot of people are replacing Terraform with Pulumi. I think the thing that Terraform really doesn't do is that bridge to the developers. And so that's, I think, the key difference is really the modern teams that we work with really want to empower developers. And developers want to be able to do it themselves as well. And it's not that they don't want to learn these things. It's that the current solutions don't have that developer aesthetic. It's not, I can't use my favorite editor. I can't refactor things. I can't share and reuse patterns. And so people get frustrated and so they're happy to just give it to the infrastructure team because they really don't want to touch it. I think that's the more fundamental difference between the approaches.
That's a good point. And I talked to a lot of developers that just want it to work. And they think, why doesn't, because Microsoft is providing Azure, why doesn't Azure just, when I hit new project and hit go, well, they have Azure DevOps and everything. How many applications ultimately are a web application and SQL Server database, and there's some other common things, but I mean, you take the combination of a web application and a SQL Server database, almost every application that gets pushed, every business application has those pieces. But why do you still have to custom create how you're going to create your app service and how you're going to spin up Azure SQL? At what point is it going to be just, oh yeah, just do it this way? Here, suck in a NuGet package and you're done putting your subscription credentials.
Yeah, it's absolutely correct. And we have a number of reference architectures for folks that want to do standard things where you don't want to have to discover. And I will say sometimes it's not even clear how these different services connect to each other. And so, the Azure console actually does a lot of magic behind the scenes. When you click a single button, it's doing a lot of stuff and stitching together a lot of services that may not be obvious. If you ever go in after doing that, you go to your resource group and you say, export to ARM template. And you look at it, you're like, whoa, I didn't know it was doing all this stuff.
Yeah.
So I think the answer to your question is the thing we're trying to do is make it easy. The easy things are easy and the hard things are possible. Where the standard architectures, you can just use a NuGet package and you're done, right? But when you do want to customize something, you've got a little bit of extensibility, you're doing something custom, your infrastructure team did already stand up the subscription architecture and you need to plug into that. Sometimes there are extensibility points, and this speaks to the fact that, ARM templates are not really an abstraction technique. It really is, it's a flat file of a bunch of JSON, directives. Because of that, basically, yes, you can get a standard architecture by copying a template, but as soon as you want to customize it, now you're in copy and paste land. And that was the thing that struck us as, hey, let's bring decades of programming language innovation to bear to solve some of these problems. We know how to solve these problems.
The Azure DevOps Podcast is sponsored by ClearMeasure, a software engineering firm and Microsoft Gold partner, empowering development teams to be their best. ClearMeasure equips developers with the DevOps tools, methods, and automation necessary to focus on building their applications, rather than wrestling with builds, deployments, or environments. Click clear-measure.com to see whether a DevOps implementation is for you.
No, just like large and small business, I think some of the numbers I saw a while ago were that most developers work for either small organizations or small teams. But sometimes the massive organizations might spend more money on tooling. So it can be a mismatched market. But if most developers are working on small teams, most developers don't have this divide of developer and infrastructure people. Maybe the infrastructure people have the Active Directory and whatnot, but when it comes to business applications, there's nobody else. So for that, how should those developers who have to do it all approach this problem?
Well, I think for them, Pulumi's frankly great. I'm biased, obviously, but
no.
But
hey, you should be.
I think of the cloud as a superpower that you can tap into to really get a bunch of great capabilities right from out of the gate into your application. You can have serverless, so you can run and scale, very flexibly based on demand. Now, sometimes you don't care about these things, right? Sometimes you just want a virtual machine. You want to keep life simple. But the fact that you can be empowered to actually use the cloud, and it's not this scary thing that you kind of like kick the can to the ops team, but you can really leverage it. Machine learning services, big data services. I mean, you can really do some innovative and powerful things using the cloud that you would not be able to do before. Like I think back, 20 years ago, the stuff you can do with the cloud today would have been unimaginable. I worked on concurrency a lot during the 2000s because of multi-core and all that. And, distributed programming has always been this thing that, programming language experts and researchers were saying, hey, distributed programming is coming. Well, it's finally here. And it's exciting. It's an exciting time for developers. And you look at some of the .NET projects that are actually aligned with microservices. Think a lot of like Akka.NET and some of the actor frameworks like Orleans. It's a really exciting time to be a developer. And I would lean into it. If I were a developer, I'd say, hey, I'm going to go learn as much as I can about the cloud and Azure and the latest services. And I'm not going to think of it as an afterthought. It's going to be part of my core, job and how I develop my software.
Okay. Now, from an architecture perspective, you've got to have an opinion on what infrastructure to pick. So, for example, it's possible to run the old background service, the long-running background service as a worker in a .NET Core web application. So, possible versus should you? What's your opinion on that? Is it, hey, this is great, and yeah, don't even worry about the old Windows services or the old Azure functions or anything anymore because it's changing? Or is this a demo thing that's just going to bite you if you actually do it?
Well, I think I would focus on, hey, what's actually going to help you create your application either faster, get it to market faster, give it new capabilities, have more business impact. There's a lot of fashion, I think, especially, you think of like in the last couple of years in the cloud space. I mean, there's a lot of distractions. It's easy to get distracted. I would say don't dismiss the tried and true techniques that have worked for many, many years. It's okay if you just want a virtual machine and you have one instance and you're going to worry about like that. That's a good day when you realize, oh no, I need to add my second instance or think about scaling because my application has suddenly become so popular. You don't have to tackle all of the complexity of having high availability, infinite scale, et cetera, on day one. I think it's easy to go overboard sometimes. And frankly, some of the newer serverless architectures do introduce new challenges. Some applications are naturally architected this way. Event-driven applications, it's actually really a good fit to do something with serverless. You have to think about, hey, these are stateless little bits of compute that scale infinitely, and that's a good model. That's not always the right model. Like if you're trying to build a stateless application using a serverless Azure Functions approach, or probably you're not going down the right path. So I would say the right tool for the right job. Okay.
Now, you probably wrestle with this problem, which is migrations. Just the architectural concept of migrations that I think it took an entire decade or 15 years of fighting in the database community before the industry has finally settled on, oh yeah, we do have to have a sequential migrations approach to SQL Server database schema changes, whereas previously there were some products that used, and ARM uses state-based approach where we look at it and say, what should it be and what is it? And then on the fly, a computer decides what scripts to generate to make a change. So it seems like any resource that can't just be totally dropped and put back from scratch is susceptible to this same issue. How does that issue manifest in infrastructure where, you've got something for a while, but now I want to make this one surgical change? How have y'all approached that?
Yeah, I think that's, the whole cattle versus pet analogy where, cattle, you're happy to just, replace the thing on the fly. It doesn't have a long-term lifetime. And then the pet analogy of like, every pet is special and you need to really think about, keeping your pet alive and you can't replace them as easily.
Right.
It's definitely real. And that's an important thing to think about. And databases are kind of where the rubber usually meets the road when it comes to database migrations. We've got some clever solutions. If you think about how a declarative infrastructure as code tool like Pulumi works, it is always trying to basically drive, it understands what your current infrastructure is, it understands what your desired end state is, and then it understands what incremental steps to take to drive the current reality towards the desired reality. But it often does that potentially through deleting resources that you don't want deleted. So we give you a lot of tools to manage that, including sequencing, database migrations as part of those. It's also one of the subtle things is we prefer to express it in an idempotent way where possible. And what I mean by that is, the unfortunate thing is if you're thinking about every possible state transition that could ever happen, you have to think about all of the possible failure cases. And if you have one environment, maybe you can do that. But if you have 100 environments, or you might, or you want to be able to spin up a new environment tomorrow that actually functions, replaying every manual change you've ever made is often not feasible. So when we work with people, we encourage them to encode these in terms of state transitions that are idempotent, so you can always replay them. And that's why the sequential database migration approach actually works reasonably well. And that is, by the way, one of the reasons we prefer to integrate with Chef, Puppet, Ansible, SaltStack on the VM management, because config management and patching and everything, they already handle a lot of those problems kind of out of the box. So that's my basic answer, but it's definitely the messy reality that people do have to face.
So let's talk about DevOps a little bit, because people who are already embracing it are used to just, I made a change and now let me run my pipeline and I'm going to go a sequence of environments ending up in production. So now I've deployed my application and yeah, a lot of people have integrated SQL migrations directly into the application, so it kind of deploys it. But now let's say you need to, I need to change a setting on my app service. Could be something simple, but hey, now I have to change a setting. It's not deploying code, but I need to change a setting combined with this. Where should that go versus the other problem of, hey, I'm not actually changing my code, but I need to change the setting?
Yeah, so that is another area where this divide between infrastructure and application deployment kind of breaks down. We find a lot of people are doing continuous deployment with pipelines and so on of their application code and container images and things like that. We often, but it's often, it's kind of a false dichotomy, right? Because you might need to tweak an configuration setting in the Azure infrastructure. You might actually have to provision a new container registry as part of your application deployment. So I think recognizing that continuous delivery of infrastructure changes is just as important. And that's kind of the next wave beyond continuous delivery of your application changes. I think that's a key insight, is that, hey, it is applications and infrastructure. It's not an either or. And then the question becomes, okay, what about the relationship between the two? As you're pointing out, sometimes they're intertwined. They're not so cleanly separated. And so that is why, we have an Azure, DevOps pipeline task that you can install out of the Azure Marketplace. And so we plug right into that workflow and enable the application and infrastructure changes to sort of live alongside each other. It's also interesting because like if you're running Kubernetes, oftentimes you do need to change the Kubernetes config. You deploy a new container image, you build and publish your application code, but now you need to go bump the reference in the Kubernetes config to point to the new image. And that's often a manual process or some bash script or something that somebody wrote versus being a real deployment orchestration. And that's kind of where we're trying to move is, hey, being able to orchestrate across these boundaries without completely different tool chains or different workflows or manual steps in between. Okay.
Now, DevOps is, I guess, it's been around for 10 years now from a coining of the term perspective. Is this where the industry is going to live, or do you see another sea change coming?
Yeah, it's interesting. I just went to the DevOps, the 10-year anniversary in Ghent. First time in Ghent, beautiful city. So it was great. I got to meet a lot of people there. And we just hired actually a marketing leader who actually led marketing at Chef for the first 5 years at Chef. So did a lot of work around DevOps. I think, to me, we're reaching the stage where, to me, DevOps brought engineering closer to operations and really helped operations and infrastructure teams adopt engineering practices to help them manage the infrastructure. And it did have an impact on some developers, but it didn't have an impact on every developer. And I think the next wave is what we're calling cloud engineering, which is applying engineering discipline to your infrastructure. So really take that DevOps idea to the next level. And I can't tell you how many people are using Pulumi to test their infrastructure in novel ways, refactor their infrastructure through normal programming language tooling. But more than that, it's now every developer can and should think about the cloud as a first-class superpower they can use in their application development. So to me, that's the major shift. And it's really this notion of, hey, every application is a cloud application. And I don't think everybody thinks of it that way yet, but that to me is the clear trend.
And for people that are using the other products you mentioned, they have a variety of the paid tier versus the free tier. What's the breakdown in Pulumi? What's the path to get started, and then what are the pricing tiers?
So Pulumi's open source. The whole SDK is open source, free to use, unlimited use for personal or team usage. We have multiple backends. So when you run the Pulumi CLI the first time, it will say, hey, where do you want to store your state? And that's really because of what I mentioned earlier. Pulumi knows what the current state is, and it knows what state it's trying to get to. The analogy I draw is sort of like Git and GitHub. You can use Git entirely offline if you want. You'd have to manage your own repos, but that's fine. Or you can use it with this online service. And so Pulumi offers an online service. Even the service itself, we have a free tier, which is different than, you can just use the whole thing offline if you prefer. You can store it in Azure Blob Store, but we offer a free tier that just makes it a lot easier to manage your projects. And then once you get to the point where you want to share it in your team, again, GitHub analogy, you've got an organization, you can invite multiple people to your project. Makes it easier for collaborating. You can always go see who did a deployment, what did they change, why did they change it, links back to the commit, back in GitHub if that's what you're using, or link to GitHub Actions or Azure DevOps Pipeline. So it has deep linking and it helps you manage projects in your team. And so that's where you have the opportunity to pay for it, but everything before that is free.
Okay, awesome. And so for people who are, it's kind of intrigued, maybe they're using Terraform or something else, and how would you recommend they get started? What should they do immediately after finishing this podcast?
Well, you go to Pulumi.com and then click the blue button. You'll see it everywhere. It says Get Started. It'll walk you through, a pretty simple set of tutorials for whatever cloud you prefer. So we've got one for Azure. We've got a Kubernetes tutorial, AWS, GCP, and it just has a lot of examples that you can get started with. That's usually the best way because you get a familiarity with the tool and how the CLI works. We actually have a tool. If you have some Terraform already and you want to see what it looks like in Pulumi, we actually have a tool called TF to Pulumi. It's on GitHub. Actually, today we're launching a new webpage for it. So Pulumi.com/TF2, the number 2, Pulumi. And it will be an online tool. You can paste some code and see what it looks like in Python or TypeScript or whatever your favorite language is. So those are good ways to get started. We have a community Slack as well. The whole team hangs out there and just slack.pulumi.com. Everybody's invited. It's a great place collaborate with other Azure experts, .NET experts, share code, share ideas. Fun place to be.
Cool. Is C# one of those primary languages?
It is, absolutely. We added C# support actually with the .NET team. We get a lot of support there. I still have a lot of friends over there. So so that's been great. Honestly, you get to do everything in C#, your application C#, code's running in Azure. It's a lot of fun. So that's been great. Just
as an aside, I lament that we don't have it yet, unless maybe I'm missing something. The on desktop emulators that we have to wait for Azure to go and do something, and the cycle time is just slow. It's like, okay, what is there any way to debug and actually run these things locally?
Yeah, so we do support things like Docker for desktop, and there are tools for debugging it locally. I would say most of the time, because the emulators aren't faithful enough, you should try Pulumi actually, because I think part of the spin up time is cut down by the workflow in the CLI that really is geared towards spinning up ephemeral environments and tearing them down quickly. And so it's really easy to just say, hey, I want to see what this looks like, create my own private dev stack, and then party away on that for a while and then tear it down. Of course, it's still limited by the speed of provisioning in Azure, but a lot of the slowdowns just tend to be in the workflow. And so Pulumi removes those roadblocks.
Yeah. Awesome. Well, hey, Joe, thanks for coming on the show and talking about infrastructure as code and Pulumi. Man, this is a good good deep dive.
Yeah, I had a ton of fun. Thanks, Jeffrey, and hope folks check it out. Always love feedback and love hearing stories of how people are using Pulumi, out there.
Awesome. And until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.